circle. So when I ask you to compare and contrast the circle and the ellipse, one thing you should realize is that when we're dealing with a circle, the standard form is equal to a number, correct? Well, now they're going to be equal to 1. So if it's not equal to 1, we're going to have to do some things to kind of make it equal to 1. Yes? No. There's the circle, the ellipse, the hyperbola, the parabola.
So that's what we write in the book, right?
Mm-hmm. All of the conic sections. Not yet.
Oh.
We've just done the circle and the ellipse. All right, so this is an ellipse. It tells you that it's an ellipse, and we want to identify the foci, the length of the major and minor axes. Well, we can do this by putting the equation in standard form. Well, this one really already is in standard form. So the purpose of doing this question is to show you where you can find the information. So you see that the center of this one is at 0, 0 because the major, the form is x minus h squared over a squared, and I know the a squared is under the x because 16 is bigger than 4.
Where did you get that? Is that on the machine?
This is the standard form for an ellipse. Yeah, this is what you were reading about the other day. Y minus k squared over b squared equals 1.
That's like a minus.
She said it was.
This is the major, this is where you find the major axis, and this is where you find the minor axis.
So why are two different equations?
So, again, this one has an orientation that's elongated so that the major axis is parallel to the x-axis because a squared is larger than b squared, and a squared is under the x. So, if you look at this, it tells us that a squared is 16. So if a squared is 16, then a is 4. And if b squared is 4, then b is 2. Well, that gives us some good information about the size of the ellipse. And because h and k are 0, we know that the center of this ellipse is at the origin. And remember, that's what happens when there's no h and k. The center is at the origin. So several of these that you practice on today will have the center at the origin. Now, here's how a and b help us graph this ellipse. If a is 4 and a was under x, I simply count out 4, and this is the vertice of my ellipse. I simply count out 4, and this is the vertice of my ellipse. Okay?
Was that about to right there?
This one doesn't work. This was an inadvertent touch of the screen. Now the b is the up and down part of this one. Yes? The square root of 16 is 4. Okay? So this goes up 2 and down 2. So try not to make these diamond shapes. This should be an ellipse on your graph. And there is some symmetry. So try not to make those diamond shapes. I know it's tempting just to connect the dots, but do make a curve. Okay? Now, it says, graph the ellipse, identify the foci. We haven't done that part, have we? The length of the major and the minor axis. We still haven't done that, but we have graphed it. Okay? So, what is the length of the major axis? Well, the major axis is from here to here. So the major axis has a length of not A, but 2A. So the length of the major axis is 8.
Is it always gonna be one, it's always gonna be,
Yes, it's always going to be
So
2.
isn't it just the diameter?
It's kind of the diameter, although this one has 2 diameters. Diameter indicates that it's kind of the same all the way around. So this is the major axis, and we call it the major axis and the minor axis because they're different. Okay, so the length of the major axis is always 2 times A. It's not the square of 8, it's just 8. Okay? And what is the length of the minor axis? 4. Now, graphing these helps, and that's always 2b. Okay? Graphing these always helps. Now, we know the foci lie on the major axis. The foci lies on the major axis. The foci is going to be somewhere in here. It's going to be along this line and along this line. Okay? But how do we determine the length for those? Well, it's the good old Pythagorean theorem that never goes away. So the difference in the one that you are going to do now and the one that you did back in geometry is C is not the hypotenuse. Yeah, we are going to make a triangle.
Oh.
Watch what happens. I'm going to take this length. I'm going to take this length. Let's see if I can make it a color. This length right here. I'm going to take this length, and I'm going to slide it. Watch what happens. I'm going to slide this up here to that. And I don't want to make it the same. I wanted to make it. What's that? Yes. This helps all kinds of. So this A slid up here. The A didn't change. All kinds of engineers. All kinds of engineers. Building all kinds of things. Oh, artists too. Okay? So this A didn't change length. It just slid up to here. Does everybody see that? That becomes the hypotenuse of my triangle. Okay? So this is A. It is the same length. I just moved it. Okay? This is B. Sorry, it's moving now. This is B. It didn't change. So C is another leg. And C is going to be the hypotenuse, the Pythagorean theorem's relationship. This is a right triangle. Do you see it? Okay? So A squared plus B squared equals C squared, but A and C have changed places. A is now the hypotenuse. Okay? There you go. So, if you're going to do 4 squared equals C squared plus 2 squared, you can find the length of C. So isn't this, what is it, 9? So what is this length going to be? Where are the foci going to be? Isn't it going to be out 3? Um, 16.
4 is 12.
Thank you. I wanted it to be a pretty number, but it's not, is it? It's not always going to be a pretty number, but it does work. I'm sorry? I don't think so. Do you need a different way? No.
12.
Thank you. So this is the square root of 12, isn't it? Do we care what the square root of 12 is? All we need to know really is that it's between 3 and 4, right? So I'm going to count out from my center between 3 and 4. 1, 2, 3. So the foci are going to be right here, aren't they? they're on the major axis, and they're this many units from the center. Because this is c squared, so you have to take the square root of both sides. Okay? So the foci are going to be negative square root of 12, 0, and square root of 12, 0. Now, if we go back to algebra 2, we could simplify this and make it 2 square roots of 3, but it might make you do that on IXL. So if we find that that's the case, we'll practice that a little more. But that's question number 1, right? Is again at 0, 0, and its major axis is under the y, so it's going to be oriented this way. So take a moment and work through this problem, graph the ellipse, identify the foci, the length of the major and minor axis. So graphing this, the center is here, and remember it's oriented up and down like this. So we're going to count up 9, so that's here, and down 9, so that's here, and then right 7 and left 7. So we need to have this ellipses. It looks more like a circle, doesn't it?
Yeah.
Okay? So this is going to be rounded, not diamond shaped. I know it's easy to make these diamond shaped, but they really should be rounded. Even that one looks more diamond shaped. I need to have that one a little more out there. But now we need to do the foci. Right? Which axis is the foci on? The up and down one. It's on the major axis. Okay? So since this one is oriented this way, the foci are going to be here and here. Okay? So it's going to be 4 square roots of 2 up from the center and 4 square roots of 2 down from the center. Okay? So what is 4 square roots of 2? If you don't know how to graph that, do in your calculator 4 times the square root of 2. What is that number? Okay. So 4 square roots of 2 is a little more than 5. So there's the foci and there's the foci. Does that make sense? If we were putting our pins in here and we had a string around these pins that would reach here, and then these 2 pins were here and we traced out those 2 strings, it would make that ellipse.
So we just do whatever C is. That's like how we get the foci.
Right. So let's answer the question now. The foci are going to be 0 because they're on the y-axis. So the foci are 0 and 4 square roots of 2 as an ordered pair, which is 0 and 5 point something. And the other one is 0, negative 4 square roots of 2. Okay? Now, what else have we not answered? Let's go back to our question. Do we write down the length of the major and minor? Well, we said it. Do we write it down? What's the length of the major? 18. What's the length of the minor? 14.
How did you get 18?
It's double this because it's 9 up and 9 down. The length of the major axis is actually looking for how many units this is from here to here.
What's that?
A? What's A? A is the length of that piece right there.
So the minus 4?
The length of the major and minor axis is always double A and B. Okay? Since this one's not in standard form, we need to put this one in standard form. And if it's in standard form, this would be 1. So we're going to divide both sides by 100 to make that 1. So if we divide this by 100 and divide this by 100, then we get 25x squared over 100 plus 4y squared over 100 equals 1. And so when we reduce those fractions, you get 1/4, or x squared over 4. Now it looks like it's in standard form, doesn't it? And what is 4 over 100? Y squared over 25. Now we can see that the center of my ellipse is at 0, 0, right? And is this ellipse going this way or this way? Up and down, because this one's bigger. So this is the winner, isn't it? Okay? So, find, now we're back to where we were for the last two. Find AB and the foci and
We're just the A and B. But it's just small.
Oh, okay.
Okay, so again, the major axis was 10, the minor axis was 4. Here's your graph. The only difference in this one is that you had to divide by 100 first so that you put it in standard form. Now, there will be some questions where you have to complete the square to find the center. So let's see if we can do that like we did before.
Look, I don't.
You don't like doing that?
No, I like doing that.
It's a bit of work. Okay, so let's try this one. This one is exactly, go back. This one is exactly like the last one. So get started on this one. Oh, come on. All right, so again, the major axis was 8 units, the minor axis was 4 units, the foci is -2 square roots of 3, 0, and 2 square roots of 3, 0, because it's over here that we have the foci. Okay, on the major axis, the foci are on the major axis. All right. Okay, so the last example. This one is already in standard form, but you see that the center is not 0, 0. All of the other things stay the same, and if you've been counting rather than just calculating, you're not going to have a problem with this one. So the center on this one is what? 2, 1, because it's the opposite of those. It's x minus h, x minus k. So use the center of 2, 1 and work this problem, finding the foci and the length of the major and minor axes. Okay, so A is 3. So from this point, I'm counting over 3. Okay, it's a little more challenging when the center's not 0, 0. From this point, I'm counting over 3. And that's the major axis. The minor axis goes up 2 and down 2. So here's my ellipse. And now I need to do the length of the major is still double A, 6. And the length of the minor is still double B, 4. The foci is going to be out. How many? The square root of 5 is what? Between 2 and 3? So it's going to be between 2 and 3 units. But it's on the major axis. 1, 2. So you see how I counted there? Okay. So the major axis is not quite as easy when the center is not 0, 0 because it's on this line. So I have to figure out what this is. Well, because before it was 0, so it looked like we were just using the C, but we were actually doing 0 plus the foci, the ceiling, and 0 minus the ceiling. So since this is the case, this is going to be on this 1. So the 1's not going to change. So the foci is going to have this 1 in it, okay? This 1 in it. But the x part is going to change. It's going to be 2 plus square root of 5 and 2 minus the square root of 5. You see how I did that?
Okay, what is that?
That's for these points right here because it's the square root of 5 from the center and the square root of 5 from the center.
Okay.
Okay? And it's fine just to write these just like this. It's 2 plus the square root of 5 and 2 minus the square root of 5. Now, if you want to give a decimal, IXL might ask you to give a decimal, but probably not.
No, that's a fraction.
They ask for a fraction. Okay, we'll see. All right. You guys have paid some good attention today. I hope you learned a little bit. We had some practice.